This is the video for notes for 2.8, which is literal equations. You need to go to the back of your packet. It's one of the last pages. So the idea with literal equations, and you can see that word literal in there, is different than the equations that we've been solving to get a number as an answer, or no solutions, or many solutions. The idea is that we take a formula that has multiple variables and move it around so that it solves for a different quantity. So the objective, be able to solve a formula for one of its variables. When you're done with these, you will still get a formula that still has all of its variables in it. You won't take it down to one number. So as you fill these in, go slowly and stop the video where you need to so that your notes will look good and are helpful to you. So equations are said to be solved for a certain variable if we can get it isolated on one side. What this means is I should be able to look at an equation, and depending on the variable that it outputs, what it calculates, that's the variable it's solved for. So in the table of examples, you've got area equals base times height. So area is the one variable alone or isolated on one side. So right now this formula is solved for area. If I moved it around by algebra, I could get it to be solved for the base or the height by getting them alone on one side. The next one down is solved for the y variable because that's what it's outputting, or that's the variable that's alone. If I take a number for x, I can calculate or output the y value from that formula. The next one down, if you don't like the order it's written in, then switch it around. And that's that distance is rate times time formula, and right now that one's solved for distance. So that verb is, that sentence or that phrase is solved for, you're going to see on homework. And that's what this means, is that that's the variable that's alone, and in homework they're going to ask you to get different variables alone from that same equation. The next one down is another one that's solved for y, because that's the variable that's isolated or alone on one side. And this final one, which is perimeter for a rectangle or a parallelogram, at the moment is solved for p. So when they give you directions, and they will on your assignment tonight and on things we're going to do over the next few days, and this comes up in science an awful lot, to solve the equation for. Not for a specific number, but for a specific variable. So if the directions are solve the equation for w, it means we have to undo all the other things that are calculating on the side with w until we get it by itself. So your notes say solve the equation for w means to undo the side with w by inverse operations. The same operations we use to undo and solve for x in equations to get an x equals equation. So solve with inverse operations. That means if there's addition, we'd subtract to get rid of it. Until w is all alone. Once that's true, then what we should be able to say is that that w is the output, the result, or what will happen if we put numbers in for the variables on the other side. So the first example you have, it says solve for w. So by the time we're done, again, go back up, means we need to undo everything that's happening on the side with w until w is alone and by itself. So the first thing I see in here with w is that w has a multiplier by 2, and it's got an add-on term of 2l. So remember when we solve, we have to think in the reverse of the order of operations. So in order to solve and get that w term alone, the first thing I have to undo is the last thing someone would have calculated. So the last thing someone would have done is add on that 2l. So on both sides, I need to subtract the 2 times the l. Now, since these aren't numbers, these two will cancel out and leave that side alone as 2w. The other side, however, p's and l's are not like terms, so the best I can do is start at the top with the p and say that on that side, 2 times the l value is being subtracted. So these aren't going to get shorter. You're not going to come down to a number. You're rewriting the equation to do different work. Our w is still our goal to get it alone, but right now there's a multiplier on it. There's a times 2. So we need to undo that by dividing both sides by 2, and this whole other side Let's cancel what we can. So this side's now just W. I'm going to write it over here where I have a little more room. The other side, however, nothing can cancel and nothing can be all divided by 2. So the result, the solving for W, leaves us with a formula that instead of getting a single number, it's telling us how would that formula take perimeter and length and then spit out width or calculate width. The next part's related. The next question, the next part of this says, for a perimeter of 84, so mark these up with me as I go so that you're modeling how you'll handle homework, and a length of 18, so this is telling me length is 18, they would like us to find width, which is the W. We now have a formula, we have 2 to choose from. We have the original perimeter formula that is up in blue right here, that we could plug those into. Or we have this one down here that says, oh, you want a width? Here's what you do with all the other parts to get that width. So this one I'm going to use right away because it calculates width right away. So I'm looking up there. It says take the perimeter number, 84. Subtract twice the length number, which they said is 18. And divide by 2. So we want to see this step where we're showing what numbers we plugged in and where. And then we can go ahead and calculate. We know order of operations says work out the numerator first. So that's going to be an 84 minus 36. So in our numerator we get a 48. The divide by 2 when it's a fraction always comes last. So the width is 24. We'll put centimeters on to have a good label on our answer. We're going to try a few more. Okay, and your assignment tonight looks mostly like what's on this page where they're asking you to solve a formula for a letter other than what it's already solved for. So I'd suggest you grab a highlighter if you have one, and if not, circle it. They want us to solve this one for L, and they want me to solve this one for T. So I'm going to identify which variable I need to get alone. That's the one I've got to undo everything around it by reverse order of operations, that solving order of operations, to see if I can get it alone. So right now the only thing keeping L from being alone is a times W. So my undo operation is going to be to divide by the W. So on the side that had L, the W's cancel, so I just have length. On the side that didn't, nothing cancels. It tells me the formula would have to be changed around in order to calculate lengths instead of taking widths and areas. So that would be my answer if they said solve that one for L. I've got L by itself now. If they asked me to use it, then I could go ahead and plug variable values in, but a lot of tonight's is just going to be moving this around. Science often rechanges the way the formulas are written in order to calculate something faster if they had to do a bunch of length calculations. The next one is distance equals rate times time. They would like time alone. Very similar to the last one, there's just a multiplier. So I'm going to divide both sides, cancel off the R. So T is now alone on this side, but I need to rewrite this side with all of its variables in its new calculation terms. I'm going to have you guys squeeze in one more in between on the 2 you have in there so that we've got one that's got a little more addition and subtraction with it. So the next one, you put it right in between the 2 you already have. The next one I'm going to ask you guys to try is taking y equals 10x minus 8 and solve it for y. Solve it for x. That means by the time I'm done, we want to get that x alone. The more samples of this you have, the easier it should make your task when you need to do some of these on your own. So my goal is to solve for this x. I know order of operations wise, the very last thing to happen in this would be the minus 8, so I'm going to have to add 8 on both sides. On this side, the 8's will cancel, and I'll just have a 10x. On this side, the y and the 8 will not cancel. They aren't like terms, and they don't cancel each other out, so I'll still have to keep the y plus 8. Dividing both sides then by 10 in order to get the x alone. I come up with a fraction on the left-hand side, and that's okay. It's a fraction I can't make simpler. Okay, you can't reduce just the 8 and the 10 because the 8 has to add to the y first. So there's our formula that's solve for x, meaning x is alone on one side, and we've reversed the order of operations in the correct order to get a formula now that will work. And then one of those, where would you ever use these things, or why does science do this? Give me a setting or an example. So you've all seen bank clocks when they tell you the time and the temperature, or other places, and they can easily convert between Fahrenheit and Celsius. The same on your cell phone. If you go to the weather app, you could ask it to give you your temperatures in Fahrenheit or in Celsius. So they've given you the formula here that represents how we change a value from Celsius. This formula takes Celsius in and sends Fahrenheit out. So at the moment, it's solved for F. So the directions say to solve this same formula for C, so that we can plug in Fahrenheit temperatures and have it output Celsius temperatures. So I'm going to move my formula down to some workspace here, and you should do the same. Writing that fraction top and bottom instead of sideways the way it is in your notes would be a better idea to help your brain see what you have to do. So we need to get this C value alone. So the first thing we would do solving-wise is subtract 32 on each side. This is just like when we reverse the directions from Miss Holschbach's room to here and here back to Miss Holschbach. We have to undo those in the correct order and reverse the directions. So this is where we're up to, and F minus 32 needs to stay that. We don't know what Fahrenheit amount they want to use. They want to be able to use this for any amount of Fahrenheit degrees. Most of you take this next part in 2 steps so that we can get rid of the divide by 5. We want to multiply top and bottom on that side by 5. And then this side, we need a times 5. We're going to need parentheses because it will have to distribute over that entire set of parentheses, meaning 5 times everything on that side. So on this side now, we've got 5 times F minus 32 as a quantity equals 9C. And then finally, we need to divide both sides by 9 in order for that C to be the output variable. So we get C alone on this side. So in other words, we can calculate Celsius temperatures by doing the entire formula over here. So we're shifting the formula's order to solve for a different variable. That's the equation that's programmed into phones, that's programmed into bank clocks in order to take a Fahrenheit temperature that a thermometer measures and convert it into Celsius, a temperature scale that's used in most other countries. The last one, find the Celsius temperature equivalent to 99 degrees Fahrenheit. So on a very hot day in Wisconsin, when it's 99 degrees Fahrenheit, we want to convert that to Celsius to tell someone who's traveling from another country, or a lot of doctors and hospitals' offices use that when they take your temperature in the office. They actually often use it in Celsius in their record keeping. So this formula that we've got right here is available to input our Fahrenheit temperature and output Celsius already, compared to the one up here that you had, which doesn't. We'd have to do a lot of algebra on both sides. This one's ready to compute a Celsius temperature for us. So that Celsius temperature is 5 times the Fahrenheit specific number that I want to use. When you start to calculate that by order of operations, you know we need to work the top out first. Okay, which would be 335 divided by 9. And on here we're going to need to round just a little bit because 335 divided by 9 is not going to be a whole number of degrees, and that's okay. So as you divide that out, let's take it to the tenths. So this would be around 37.2 degrees Celsius. So when it's a really hot day here and we are sweating and everybody's going to swimming pools, if someone from Europe came and we told them that it was 37.2 degrees, they would understand. When we say 37.2 degrees Fahrenheit, that'd be a totally different Celsius temperature. So when you're doing homework, there's other short videos posted in case you get stuck along the way on a few homework problems so that you've got some guidance. You can also ask the person in the room helping today.